All right, let's jump right into this explainer on exactly how construction materials companies measure, track, and report their massive energy footprints using the SASB standards. Think about the sheer scale of producing cement, glass, or crushed stone. I mean, we are talking about some of the absolute most energy-intensive manufacturing processes on the entire planet. So today, we're going to unpack how the Sustainability Accounting Standards Board, or SASB, forces these companies to actually report that energy used to their investors. We're going to zero in on one highly specific, highly structured metric, a metric that takes this incredibly complex web of fuels and power grids and translates it into clear, comparable data. This quote straight from the standard. It really hits the nail on the head as to why we're tracking this data in the first place. In the construction materials sector, your energy efficiency quite literally dictates your profitability. Because these operations require such extreme heat and heavy-duty machinery, having affordable, reliable energy isn't just nice to have, it is a major competitive advantage. So we're not just looking at this from an environmental, let's save the planet perspective. We're looking at it because a company's energy strategy directly impacts its bottom line, its exposure to crazy fuel price swings, and its vulnerability to future greenhouse gas regulations. And sitting right there in the SASB disclosure table is the energy management topic, specifically metric EMCM130A.1. This one single metric demands a highly standardized breakdown of a company's entire energy diet. It's essentially designed to give investors a crystal clear picture of exactly where a company is getting its power. And knowing that, in turn, reveals a ton about their operational risks and just how resilient they'll be in the long run. So here is our roadmap for today. First, we'll look at total energy consumed. Second, the grid electricity slice. Third, alternative energy sources. And fourth, the rules for renewables. Let's start right off with Section 1, total energy consumed, and how we establish that baseline. The absolute crucial point here is that every single drop of fuel, whether a company is buying it from the outside or generating it themselves on site, has to be converted into one standardized unit, the gigajoule. Think about a massive cement plant for a second. They might be buying electricity by the kilowatt hour, literally burning tons of coal, and maybe running some solar panels on their warehouse roofs. Well, the SASB standard says all of that diverse energy consumption has to be aggregated and reported as one single total figure in gigajoules. It's the great equalizer. It allows analysts to take the raw energy intensity of a glass factory in Europe and easily compare it to an aggregates quarry in Asia. Now, you might be wondering, how on earth do you accurately convert a giant pile of coal or a massive tank of biofuel into gigajoules? Well, to get that accurate total, accountants have to use what are called higher heating values, or gross calorific values. These are either measured directly by the company or pulled from standard Intergovernmental Panel on Climate Change tables. This rule is super important because it ensures different fuel types are measured consistently based on their true maximum energy content. There's no room for fuzzy math or accounting tricks here. You have to report the actual maximum energy you're feeding into your operations. Once we actually have that massive baseline total in gigajoules, the standard makes us carve up the pie. Out of that 100% total, companies have to calculate and report three specific, distinct energy slices: their grid electricity, their alternative energy, and their renewable energy. So let's break down exactly how companies calculate each of these slices. Moving right along to Section 2, the grid electricity slice, where we measure indirect power. The math on this one is pretty simple. You take the purchased grid electricity and divide it by your total energy consumption in gigajoules. But simple doesn't mean unimportant. It's vital. Why? Because heavy reliance on the grid completely exposes companies to indirect Scope 2 greenhouse gas emissions. If a manufacturer is yanking enormous amounts of power from a highly carbon-intensive, coal-heavy local grid, they are inheriting that exact carbon footprint. By isolating this specific percentage, anyone looking at the data can instantly see how exposed that company is to future utility price hikes or stricter regional grid regulations. All right, Section 3, alternative energy sources and how companies are turning waste into fuel. Now, this is where the construction materials industry gets incredibly creative with what they are willing to burn in their kilns. To calculate your alternative energy percentage, you can count some
Wild sources. We are literally talking about scrap tires, spent chemical solvents, waste oils from other industries, and even agricultural leftovers like rice husks, coffee husks, and peanut shells. Animal meal and sewage sludge actually make the list too. Using these kinds of waste streams is a brilliant way to slash fuel costs and actually reduce overall greenhouse gas emissions. But, and it's a big but, the standard makes it clear that burning alternative fuels requires intense, careful management, so you aren't just releasing harmful air pollutants instead. It is a really delicate balancing act between saving a buck and maintaining strict environmental compliance.
And that brings us to Section 4, the rules for renewables, and the strict protocols surrounding green energy.
So what actually counts as renewable? The standard defines it pretty clearly. It's energy from sources replenished at a rate greater than or equal to how fast they're depleted. Things like wind, solar, geothermal, and hydro are no-brainers, right? But biomass gets some special scrutiny. If a company is using biomass as a renewable fuel, they can't just throw any random scrap wood into the fire and call it green. It absolutely must be third-party certified by recognized bodies, like the Forest Stewardship Council or the Sustainable Forest Initiative. The standard demands hard proof of sustainability. But here is the kicker. You cannot just claim you're using renewable electricity just because you paid for it. You have to follow these extremely strict steps. Say you have a power purchase agreement. You must explicitly retain the renewable energy certificates, the RECs, or the guarantees of origin. Then you have to officially retire or cancel them on behalf of your specific entity. You can't double dip by selling those credits to someone else while still claiming the green energy for yourself. And then there's step 3, which is crucial. You must strictly exclude the uncontrollable renewable portion of your public grid mix. If the city you operate in just happens to use 20% wind power naturally, you don't get to claim that in your renewable percentage because it's completely outside your direct control. The SASB standard only rewards deliberate, provable green energy procurement. So, bringing it all together, by forcing companies to report their total gigajoules and these exact percentages using such rigorous rules, SASB opens up a massive window into a company's true operational health. When you're looking at this data, you really have to ask yourself, are you just seeing a company blindly complying with a metric, or are you actually looking at their blueprint for long-term market dominance? Because a construction materials company that has mastered its alternative fuels, aggressively secured verified renewables, and drastically reduced its reliance on a volatile public grid, they aren't just checking off some sustainability box. They're actively engineering a lower cost structure and building a significantly more resilient business. Thanks so much for joining me for this explainer, and next time you're looking at these industrial giants, I highly encourage you to view their energy mix through this exact lens. See you next time.